announcement I want to mention is the Greater Houston Ham Fest has a date change. Instead of March, the first weekend of March, we had to back it up a couple of weeks. It'll be February 20th and 21st, 2026. So unfortunately, we had to move, but nothing else has changed. It's be just the dates, 20th, 26th. The 19th will be set up during the day between business hours, but set up only, no sales. Set up on Friday morning, and then the Ham Fest will be from noon to 6 p.m. and then on Saturday from 8 to 3 with the grand prize raffles at 2 p.m. as always. So I think some of the times are wrong on the website under hamfest.org, but that'll get straightened out over the weekend. So anybody have any other announcements? Going once, going twice? Don't forget the ice cream social coming up in October. We'll have it right here. We'll be serving the best ice cream in Texas, maybe. So, BVARC food team. We have one member here who unfortunately won't be here, but we'll have the BVARC food team out here dishing it out to everybody. So it'll be a great, yes, we'll shoot that. But anyhow, great ice cream, and Rick Hiller, W5RH, will be having a presentation in the background up here on the monitor on his antenna programs. So it's really great. It's a short presentation, not really a presentation, just a PowerPoint in the background for everybody to take a look at. So anything else from anybody else? Going once? Mike, go ahead.
Is Blake in the room? Or the control operator Monday night?
Blake, come on, right here.
How many people did you have check in Monday night?
Last Sunday night, I believe it was around 5 to 10. I can't remember
This past Monday, it was like 19.
It varies. It's jumping. It's getting higher.
19 though.
Yeah.
Wow.
Didn't you run it this time?
No.
Because
I thought you were.
I'm this Monday.
Okay. You were ready this past Monday, you did a great job, and 19.
Yep.
This helped with the loadout bags and just kept having people check in. It's great.
It's
Like the old days.
yeah, it's growing. So the more the better. So in case y'all didn't know, one of the highest numbers on check-ins for the Monday night net was 65, I believe. So we got a long ways to catch back up. So we can do it. We got 300 members in the club. We can at least get 65 out there.
I guess that's a good time to put an announcement out that this Monday and also every Monday, different neck controllers, 8 p.m. on using N4HPG Monday night.
So Blake, are all the net control spots filled now? Okay.
We got Chuck Brown in 5CHP, myself in 5PA,
Mike, take it like this.
and then Terry, K5PGN.
I thought Terry was doing the 5th Monday.
4th and 5th.
4th and 5th. Okay.
9-4. 9-4.
Same 9-4 repeater pump. I think you're familiar with it, right? Yeah. Sounds good. We'll keep you in mind. Okay, nobody has anything else. Our presentation tonight is from Bill Crowell, N4HPG. Him and his wife Dasha made the long trip from Friendswood up here through the heat and traffic and the mud, the blood, and the guts and the beer, or something like that. And he's going to be talking about, I always forget.
Tilted, terminated, folded dipole.
Tilted, terminated, folded dipole. It's a magic antenna, isn't it?
Some would say that.
Some people say it's not even an antenna. It's nothing but a dummy load.
Yeah, you're a cool dummy load.
That's right. So I want to turn this over to Bill. And Bill, it's all yours.
Thank you.
You can use the microphone or not?
Yeah, I'll do this one because I'm in walking from the slides.
Right.
I forgot my laser.
Thank you, Bill.
Let's get this started. Saving computer battery, but not putting it up just a moment. Okay, so
The tilted terminated folded dipole. Raise your hand if you know what this is. We've got 3 hands. Raise your hand if you know what a regular folded dipole is. Okay, so the terminated folded dipole operates on roughly the same principles as the regular folded dipole. So let's do some background about what happens in ham radio. We have bands versus assigned frequencies. Broadcast stations, your AM broadcast stations, even your HF long wave stations, broadcast stations are assigned frequencies. It's our service, there's turned up the audio there. So it's amateur, military, and maritime services. We have bands, or in the maritime services, they have assigned HF frequencies within different bands. They're not used very much anymore, but like the primary maritime distress and calling frequency was 2.182, I believe it was. There's a 4 megahertz frequency and so on. So it gives us interesting limitations. So ideally, each band would have its own dedicated antenna. You know, if we lived, you know, on acreage, I've known guys that have stacked mono banders on 40 on 120-foot towers. And that would be great. Some of the bands that we have are harmonically related, 7 megahertz and 21, for example. So 40 meters and 15 meters are harmonically related, so you can use an antenna on one antenna for 7 megahertz will also work on 21 megahertz. And that was something we did as a practical training lesson with our new ham, A.T. Ross, N6ATR. So he and I built that in his yard as part of his first ham experience. So the multiple HF antennas require multiple physical space. Most of us are on suburban or urban lots. And it's just impractical to have multiple antennas. So, like I say, we live in an imperfect universe. You need to realize that any antenna that we have when we're trying to go and operate multiband is going to be some compromise somewhere. Be a trapped dipole. Everything has, there's no free lunch in electrical engineering. So let's take a brief visit about this. When you look at your AM broadcast towers, here's my favorite old AM station in Charlotte, North Carolina, WBT. And if you look at the base of the AM broadcast stations, you'll see that for these towers, they have the matching networks out here. They run coax cables to they call them a HUD, and inside there is a matching network that they use to tune or do the impedance match on the antenna. So the tuning is actually done there. And just as a side note, WBT, my old friend, was a source of great RFI back in the day on my POTS lines. But it was a friendly ADF navigation target when I was learning to fly. One of the things I would do by default when I was in the aircraft is I'd set, I think it's 11:10 a.m. I would set the ADF to 11:10, and I always knew that I had a path to the Douglas Airport on 36, runway 36, if I could do that. Some personal anecdotes here. If we look at maritime, ships and boats, they have the same space limitations, but they often even have more antenna limits. They have for HF. They typically run one wire antenna, or it could be simply a backstay. You can't put anything else for HF or on a boat. It's just impractical. But the proper installation for these things is they have the matching network, a tuner that's at practically to the base of the antenna. It's inside the hull, so it can be protected from the weather, but it's not at the radio operating position. And that's a normal feature of the maritime industry. Saltwater is an excellent ground plane. Ask anybody who operates at the beach. And just on the side note, I have a Global Maritime Distress and Safety System Operator and Maintainer license and a second class radio telegraph. I got bored. So I learned all about shipboard systems. Here's a great implementation of a antenna tuner that's actually tuning the antenna. And this picture just happened to come from Paul, Oscar Mike 0 Echo Tango in Slovakia. This is on the top of a 5-story apartment building, and his long wire goes to the top of another 5-story apartment building across the complex. Paul is a madman. God bless him. And as another aside, I have another call sign, Oscar Mike 9 Hotel Papa Golf. I am also licensed in Slovakia, and my future station in Dubrovka will be on the top of a 5-story apartment building. And my in-laws have known all of the neighbors there since, Dasha, what year was that? Like you moved there in 1977? Yeah, back in the good old days of communism. So my Olga and Andre, my in-laws, her parents, know all the neighbors, so I'll be putting up a station, but I doubt that the other neighbors in the other building will be run a long wire across the parking lot. So here's the typical ham radio station. Repeat after me. Trans matches do not tune antennas. The antenna tuner here is not tuning your antenna. It's tuning the system. In the old days, we didn't care about we use antenna tuners because we care about SWR with solid state files. When I was first licensed in 1982, many people were still operating radios that had 2 finals. I had my first HF radio was Kenwood TS430 that was one of the first synthesized solid state radios. But many of the radios that were transistorized still had 6146 final amplifiers, and you had to tune them like Kenwood 520. So when you're tuning, quote unquote, tuning your antenna, this is 50 ohm coax, this is a 50 ohm radio, this is a 50 ohm port that's going into the input of your antenna. The coaxial cable going from here is 50 ohms. You're going up to the antenna, but because of the mismatch, you've now got an impedance vector that has to be resolved so that your finals will work and the radio will not fold back. In the old days, we had people blow the finals much more than we do now because the fold back circuitry was not so good. When you do this, you're getting convenience, but you're turning the mismatch component of the vectors within this complex impedance into heat along the length of your coax and inside your tuner. But it's convenient, but it's not, quote unquote, improving your signal because it's making the radio always see 50 ohms resistant for its output. The radio puts out more power because the finals will go and push the power, but that which would be the reflected or the complex vector is being resolved within the coax. So you're abusing your coax. Now, QST quantified this back in an episode of the QST in the 1980s. I don't have that copy. I don't keep those copies. As a side note, when you're going and tuning through a balun, especially the small balance that most people are using on the infed half waves, you're oversaturating your course. So when you have an infed half wave antenna, it's a half wave on one frequency, or it's a half wave. It's a multiple half wave. So if you have a 40 meter infed, it'll work on 15 because it's 3 half waves in terms of wavelength. So it still resolves the same for the impedance. But when you're going and using your 40 meter half wave on 10 meters, you're going and making your complex vector being made up with the transmatch coax and then the unknown that is allowing you to operate that NFET half width. And so we're seeing people saturated cores, splatter signals, and burned up cores, especially at high power. That being said, it's very, very convenient, and I wouldn't say not to use it, but there's not a free lunch. You're not improving your signal. But once again, we have bands, we don't have channels. So it's convenient for us to be able to do it. And yeah, I still have a tuner for reasons I'll talk about in a minute. So, what is the tilted terminated folded dipole? It's an ultra-wide bandwidth on one antenna. It was developed by a guy named Geo Countryman. He built it for the US Navy starting in the 1940s. It's extremely broad-banded, minimal VSWR. And it lets you do interesting things like automatic link establishment. Does anybody know what that is? Okay, we've got one. ALE is a system by which your radio equipment can attempt to establish a link with another station, and it does it by changing bands and frequencies to try to find a propagation path that the two radios can agree on. It facilitates that because it's going and it doesn't have to go through a tuning cycle for the antenna tuner to do that other station. And the other station is not having to listen and reset its tune. So it's very convenient for ALE. So who uses the tilted terminated folded dipole? U.S. embassies, and I would go on good authority that the CIA used to use it when they were on HF. The military uses it, and doomsday prepper ham radio operators like me use it. So here's an image of one that I pulled off of Palomar. So the folded dipole, the terminated folded dipole is a folded dipole with a spacing at least 1/100th of the wavelength. So it's usually 16 or 14 inches between the top and bottom of the antenna. It is a balanced antenna, so you'll see an actual balun. We're actually going to use a balun here for a reason, which is for impedance matching. That's ultimately what a balun is for. It's not, there's no magic to balance, but it's a high impedance antenna. The impedance is determined by the spacing and by the value of the terminating resistor. It is a traveling wave antenna. It's not a standing wave antenna. So those of you who are building your half-wave dipole and you're cutting them to length, you're tuning them because they're operating in a standing wave mode and you're trying to make them resonate on that particular frequency that you're tuning. This is a traveling wave. So the signal goes into the bottom, it travels around the antenna, and the phases cancel at the terminating resistor. And it's all about impedance matching. So the idea is we want to have 50 ohms at the radio. We have 450 or 600 ohms or even higher at the antenna because of the terminating resistor and the spacing. And you must use a feed line choke at the input to the balun, and we'll talk about that more later. So why did I choose a TTFD? At the time that I was first doing it, we lived in, Dasha and I had moved into her condo in Charlotte, and we were on the top floor, and I could get into the attic, but we were in downtown Charlotte, and we had incredible noise. So I got researching noise rejecting antennas. Because it's a balanced antenna and noise is usually vertically polarized, it operates in common mode as opposed to differential mode. So the currents are applying equally on both sides of it, which that when they reach either the terminating, when that current reaches the terminating resistor or the balun, those phases tend to cancel each other out. So if you have a nice differential wave, which is what we want for radio communication, the antenna will apply that and you'll have a difference across the balun. So it's common mode versus differential mode. And the same feature you can find in balanced microphones. They're noise rejected for the same reasons. I also wanted to be able to quickly QSY without retuning, or perhaps introduce ALE. So I got started in it, and I've tended to use it ever since. So my first one was a Barker and Williamson. It was affordable back then. I'm going to show you their price sheets now. It has their 12-to-1 balun at the bottom, their terminating resistor. I've noticed that it generally just sucked for receive. Also, the resistor network was 100 watts. I'm a DXer, I don't run a kilowatt. Don't think I have enough. Oh, iron core balun. Yeah, I took a bandsaw and cut this stuff apart. And what I found inside shocked me. Instead of nice ferrites, a good balun design, it was some magnet wire on an iron core. The SWR was ultimately flat, but it was sort of like a big resistor. But they sell these all day long to the military and the government. Of course, I don't know if the military and the government take them apart with bandsaws. So here's the prices. Your 1 kilowatt folded dipole, $1,900. Of course, that is the 1 kilowatt, but you can see those prices here. Here's a few more pieces. $700 for the balun. Balancing network is another $700. And so I'm going to do since I can draw on the whiteboard, I'm going to draw a picture of this later because it makes it easier. I wanted to use a 1500 watt balun and terminating resistor. That's heavy. So putting that on the dipole is a mechanical issue. It makes it heavy. But you can feed it with ladder line. How many of y'all have ever used ladder line? A few of us. So I just copied this image. Place your balun someplace convenient and run a ladder line up to it. Jerry N4HPG is running 450 ohms. He's using the ladder line. You'll see mine in a minute. So I needed a high-powered 12-to-1 balun because I was operating at 600 ohms. And so I took it as a retirement challenge. So I developed a 12-to-1 compound balun based on Jerry Sievek's book. So here's one of them that I built for a friend of mine up in Canada. That starts on the top with a 50 ohm choke. It goes to a 1.5-to-1 unund, which goes from 50 to 75 ohm. Then it goes into a 9-to-1 Guanella balun, which is made with 200 ohm spaced parallel lines, because 3 times 200 is 600. It was 2 years of work, and it was before we had these nifty VNAs. So I used a poor man's time domain reflectometer to measure my strip line impedances.
There's no poor man's TTFD.
So the poor man's TDR was an oscilloscope, a signal generator. I take a 1 meter long piece of test line and a linear taper carbon non-inductive pot. And you take the pot and you look on the scope until it dips. Then you disconnect and measure it with an ohm meter, and that tells you the impedance of that line. Like I said, this is a 2-year project, but this is a 1500 watt rated. This will easily do it all day long. It was also, there was finding out the right ferrite material to give the impedance curves that I wanted, and then the The 1.5 to 1 unon is a real mind bender until you look at it really carefully, and CVIC doesn't make it easy on you because his example shows all these soldering things in there, and you can actually turn it much easier. It did have disappointing bandwidth. I was not really happy with it, but I used it. The reason I didn't bring this to y'all and really extol it earlier is this is outside of the construction capabilities of your average hand. I don't see your average guy going and putting a balun like this together. It's a lot of work. Blake's raising his eyebrows. Blake, you could do it, but you're an electrical engineer. So the fabrication, and this is Teflon wire. I mean, it's a challenge. Input chokes. One of the things I learned in this process, though, is input chokes are essential for things like 9 to 1 and 12 to 1 balance. The top of that became critical because I deployed it initially without it. When I went to high power, the RF just blew through the shack and the interference was incredible. And what I found was when you go into things like unons and balance, most of them don't have a choke. You're going and spilling RF around the outside of the coax because you're not stabilizing that 50 ohm impedance right there at the input. It's behaving differently going around the coaxial cable, so it needs to be choked. So if you're running 9 to 1 balance on your antennas, or any balun, I recommend choking it. And you'll get much better results. You won't have RF on the feed line. Things will operate better. So the terminating resistor was the next challenge because it needs to be non-inductive. So here was one of my first attempts at a non-inductive terminating resistor. These are 100 ohm, these are 50 watt thick film resistors. The one that I have in the example here that we'll pass around is 100 watt thick film resistors. I use an aluminum bar for heat dissipation or an aluminum heat sink for heat dissipation. At some components of the frequencies, that power that would otherwise be reflected at that particular frequency on that particular antenna does go through the terminating resistor and is dissipated as heat. It just depends on the band. But remember that it's essentially one spot where I'm dissipating it versus through the coax and through the antenna tube. So like I said, in engineering, there's no free lunch, and this is where you pay for it, but you get a lot of convenience with it. So then I wanted to build 600 ohm ladder line, and like an idiot, I was fabricating it using Teflon coated aircraft cable because I bought a bunch of that surplus. It's a real pain to fabricate with Teflon, but now you can also get 600 ohm spacers that you can run regular 14 gauge wire, and spacing is about 3 inches with 14 gauge wire will give you a 600 ohm. The antenna that I had put up was killed by Hurricane Harvey. You may have heard of it. So here's my current antenna. It's 65 feet from end to end. It's got 16-inch spacing. This is up 50 feet in a tree. Here's the ladder line. It's got a 600 ohm termination. It's up on the other side of this, you can't see it. And after Harvey, I got smart. It's a 600 ohm impedance antenna. So what do I care if there's 4 ohms of resistance in the wire? As a function of the overall impedance of the antenna, it's true. So I fabricated out a 1/16 stainless wire rope. I've got PEX spacers and the PVC center bracket. And with a 65-foot antenna, It operates from 1 to 54 megahertz with the new valve. And also since I started this project, our friends at Palomar Engineers make excellent ballads. And I've got one here on the table that's an example. Those alligator clips are right around the antenna when it's not being used because of thunderstorms. So I've got 100 feet of LMR 400 that goes into the shack, goes around the house. Ideally, I would bring ladder line as close to the shack as I could, because ladder line is a lower loss than coax. Once again, it's convenient to run it around the house. I'll draw this diagram because of the weight of the terminating resistor and the stress that it can put on the structure. You can run one piece of ladder line up to the bottom of the antenna at the bound, and another from the top of the antenna at the meet point back down to a convenient place and put the terminating resistor. If you need me to draw that on the board, let me know, and I'll draw it with a marker. I don't have any nifty design software to write to show that, but it's a mechanical, it's for convenience. So here's the inside of one that Palomar sent me. I ordered it without the, they sort of pop this with some spray foam that sticks it all together mechanically. I ordered it without that. They have a very nicely designed, and this is a 12-to-1 balun. It's TTFD wire. So the regular one is foamed. Some people have commented that, gee, the wire gauge is pretty small. If you do the math, at RF, 1500 watts, the RF voltage is 1376 volts. So you're not pushing a lot of amps out of it, but you're raising the volts up there. But that's also a caution. You don't want to put your 9-to-1 or 12-to-1 balun connections where people can get at it easily when you're transmitting, just because it's a shock hazard. So it does raise the voltage. These are affordable. They're brilliantly affordable. I now have spares because of lightning. So here's the high power terminating resistor. So these are TO247 cased thick film resistors made for the power industry. And it's mounted on a heatsink from Amazon. How much signal is dissipated? Some people say 30%. There's all sorts of, it'd be a shame if everything on the internet was true and then you could trust it. So I'm saying compare this to a coax with a tuner. Yes, sir?
Are those mechanical instead of solid?
No, they're soldered. I did put mechanical reinforcing. Actually, you see it there, I cut the barrels off of the spade connectors and used those to hold the wiring while I soldered it to make it mechanical. You could use mechanical connectors. This is also out in the environment. It doesn't really matter. Rainwater on stuff. If you had an icing, you would want to deploy it differently.
Just showing the other guys who's talking.
Oh,
They wanted to see who was talking.
hi guys. So this is because before somebody goes and points out, that's not a 600 element resistor. This is one I made for Jerry and 5FWB. He said, Bill, would you make me one? I said, yes, you're my friend. Okay, so what does it look like? So now that I have that nifty nano VNA, I went and banged this thing against 1.82, 54 megahertz with the nano VNA, and you can see the BSWR curve of it. Performs very well. You take 2-to-1 being sort of your big limit and 3-to-1 being your really hard limit. So most of the time I don't need to use a tuner with it. Our radio will handle the peaks at 1.7 SWR, 1.6, 1.7. My linear amplifier does not, because Kenny Cam3 Cam decided that linear amplifiers should disable themselves if the SWR is above 1.5, which is highly inconvenient. So I did use some auto tuner there just because it's convenient. But once again, the mismatch is not so great. I'm creating a lot of power dissipation in the coax. So how does it work? Because that's ultimately what it's all about. I'm a DXer. It is not a beam. It is a dipole. It works just as good as any other dipole that I've deployed, possibly a little less efficient than the G5RV that I've used. I had a 108-foot G5RV. That's a well-performing antenna. I work real wide on 20 meters. Some cautions. Just in general, digital modes are 100% duty cycle. You need to take that into account with any antenna system that you're deploying. Ronnie and 6RAM and I had this conversation because he kept burning out his ununs on his input halfway. So all bands have power limits and duty cycle ratings. Read your data sheets and respect them. If you're running FT8, go and crank down the power because you're just not going to put 1500 watts through most components of those power levels and at that duty cycle. So my installation, I have a 30 feet of water pipe mast sister to a 50-foot tree that holds the pulley up above the tree branches mostly. 20-foot water pipe mast in the back corner, you'll see it there. And I got funding skills in rigging. So I learned how to make proper eye splices and double braid. And I use polyester for UV resistance, movable stretch. And like I said, the antenna and the ladder line are constructed of stainless. Remember, stainless is a noble metal. You can't solder to it. You have to make all of your connections mechanically. We'll see that later. Craig and I had a conversation about that in the repeater, so I added a slide at the end. So here's my pipe sister to the tree. So the pulley is all the way up there. The tree's grown a bit. So periodically this gets raised as the tree grows. And Pearland is now an HOA. They prohibit new towers within the city limits in violation of state and federal law, but you have to take them to court and pay $20,000 in attorney's fees to get your permit. And for those of you thinking, well, you should just put up a tower and not tell them. My wife is a licensed professional engineer in the state of Texas, and I can't complain ignorance about permits. So, here's the corner. It's 20 feet, braided rope, and the pulley's on an offset arm. It's got a pivot on the top, just a bolt and pipe cap. You notice the small line. It's a positive pull down. I learned something in Harvey when the previous antenna separated. It left my rope stranded at the top of that 50-foot pulley on the top of that tree, and I couldn't get the rope down and had to hire a tree man to take it down. So both ends of the antenna, both ends of the rope have positive pull down ropes. So if your antenna parts in the wind, you can still pull the rope back down. Let's see. The rope goes through the pulley and is tensioned with a weight. So I've got like 15 feet or more that the tree can move in the wind. And that weight, right now it's just a dumbbell. Instead of working out with it, it's on the antenna. It goes up and down, so when we have winds, you can watch the weight go up and down. And there's a 1/16, you can't see it on the photo even, there's a 16th inch stainless backstay that goes to the neighbor's fence. You get neighbor, and allowing me to use their fence on their property to anchor my antenna masts. When we've had Hurricane Beryl and stuff, they get free generator use. Okay, so we're right here at the end, just working with stainless. You can't solder to it. not with anything you and I can use. You must use aluminum pin connectors or brass bronze bolts. So at the top of the antenna where the resistor network connects, that's currently there, I have brass bolts. Stainless is very, very hard. You cannot cut it with regular wire cutters without destroying the regular wire cutters. So I use Nipex brand from Germany that are hardened tool steel that are rated to do that. Here's a ferrule that's aluminum. So wire goes through it, and you can get these off of Amazon. You know, you can always build it out of copper wire. With the strain relief, it would probably be fine. But if you want to be an over-engineer like me, stainless. And then here was a sort of a digression in the project. I was tired of tying stupid-looking knots, so I learned how to do double-braided ice places, which is something out of the nautical industry, and that was one of my better results. I'm very proud of that. So, recommendations for you. Use the 450 ohm spacing. You can buy 450 ohm ladder line all day long. 9-to-1 balance are easy to find. Palomar sells good balance. Now they have Terminated resistors, but they only go up to 600 watts. So if you want to run a kilowatt, you'll need to fabricate your own Terminated resistor. So you can copy my fabrication method. There's no patents on that. And I source the resistors from the EBG prototyping store. You will be contacted by a manufacturer's rep saying, gee, Mr. Crowell, wouldn't you like to order these? They come in 50 lots of 5,000 if you establish an account with our electrical suppliers. No, I'll just take the 20 from the prototyping store. Or you can bribe me to fabricate one of these for you. That's what Jerry did. So, questions?
You find EPG more cost effective like Elder or HP or something like that?
They don't, I have not found EBG thick film resistors on those sites, or I would buy them there. They're typically used in industrial control systems, variable frequency drives, power supplies, things like that. They're typically for industrial users. You don't see them too much in the electronic space. But great question. Yeah, if I could use them, I would.
Good thing you get that from like Dale or Shea or whatever like that, right?
You can try. I haven't looked like in the past couple of years, but you know, you can always try. But they're thick film. They're TO247 case. They're not typical electronics thing. But I tried Mauser. I tried DigiKey. I think I tried a couple of others. But now knock yourself out. John, you had a question.
Yes, if you wanted to know something like this, then only compromise and only do 40 years, 15 years. Would that simplify your construction?
No. It's basically, you can make the antenna physically shorter because the overall length of the antenna is proven to not be terribly critical. It tends to like to, the rule of thumb is you want to make it a half wavelength long on the lowest frequency that you operate. But in the testing I've done, because I made it 65 feet long, which is a half wavelength on 20 meters, which is the band I use most. But I'm using it on 40, 80, and as you can tell, you can put it on 160. So it doesn't really matter. It seems to be very broadbanded. So it does alter the performance of it. Now, I left this out. I should have had it in here. Years ago, when I was working on this project, our wonderful Rick Hiller was trying to go and model this in the various Dipoles, antenna modeling software. And at the time, with all of, Rick's a wizard, he couldn't get the software to give him a solution for it because of the terminating part of the design. The software wouldn't resolve for it. I don't know if some of the new, I haven't talked to him in a long time. I don't know if the newer modeling software can handle the terminations or not. But So it's not something that you can model and say, here's a better design for you. Not that I know of. And you'll find all sorts of stuff online saying, these are the greatest things since sliced bread, and the others is, it's an air-cooled dummy load. See, it's got a resistor in it. So, well, if I'm working South Pacific on 20 meters, it's not an air-cooled dummy load. More questions? Yes, Paul?
Yeah, well, about the second, third slide, if you had a bunch of license $2,000 or $3,000 for it, and
That-
it all up about 10 or 15,000, what was that?
Those were the prices at Barker and Williamson. Barker and Williamson used to sell into the ham market. The antenna, when I first bought mine, it was like $200 or $300. But they got tired of ham radio operators and they fell to the military. And so those are their prices at Barker and Williamson. The prices that I was recommending now are this equipment is from Palomar Engineers. They've been supplying the Baron that I use, and then they have Terminators, and their stuff is affordable. But I wanted to show that, saying, no, I didn't spend $7,000 on this from Barker and Williams.
That's what I was wondering.
Yes, sir. Yes, Dan?
I'm a chemist, so bear with me here. You're using 600 watts, well, say you have a 1,000-watt transmitter, you're putting out 1,000 watts.
Right,
There's a certain amount of energy that's going out as a radio wave.
right,
There's a certain amount that's being dissipated in resistors, right?
yes,
So you come and work with that rate, you're trying to radiate as much as possible.
exactly.
How much of the power is being converted to heat because of resistors?
The truthful answer is I don't know. And I have not been able to come up with a way to quantify it until recently. And it's an experiment that I might do if there's more interest in it, which is to use a heat gun and measure the heat rise in the heat sink and then do a thermal calculation of it. But as I said before, Rick and I worked, he was trying to model this in the ECNEC or whatever software, and it wouldn't model it even. It ran home to mama. So we don't have a way to come up with a theoretical amount. Any other questions? Yes, sir.
Just an observation, my owner lives up in the St. Louis area, he's really, really big into Mars. And that's when he got set up in his backyard, because one of the requirements of Mars is that he has to be ready at a moment's notice to broadcast anywhere from 2 megahertz up to 30 megahertz.
Yeah, and that's why the military uses it. The other thing that is nice about it is if you switch bands, so let's say you have an antenna tuner and you've tuned an antenna for any given band, and then you QSY. Your system is now tuned for the old frequency, and that antenna tuner is acting as a pre-selector to your radio, which means that if you're listening on receive without retuning, your received signal level will be much lower, so you have to retune. But if you use this antenna, you're always matched to the radio, so you can go and use it for receive. So I do shortwave listening, when I'm not talking on HF. I'm usually monitoring like U.S. Air Force frequency, listening for, emergency exit messages. So the receiver works basically across HF without having to retune. Any other questions? Yes, Mike?
Besides those resistors there, what about, you may have already covered this, like the wire wound high wattage resistors?
Wire wound. Wire wound resistors are inductive.
I know, but
Okay, so what you've done when that's one of the problems with wire wounds is even the quote unquote non-inductive wire wound resistors are usually inductive or can present interesting impedances at RF.
I was covering all
But
these.
no, absolutely is a great question, and that was one of the things that led me to trying to find, how do I make a 600 ohm, 600 watt resistor. And that was the challenge, is those resistors are relatively scarce in modern usage. No, and if you go onto the Amazon and stuff and you say you want a non-inductive resistor, they'll show you something from China that's wire on. So no, excellent, thank you. I should add that to my presentation for some time. Any other questions? Yes, John.
I did a presentation on the LKJ Wednesday night special. And one of the things I did, I like to comment about things on the internet. So I copied the design off the internet, and they had bags. It's short and had 50 feet long coils in each leg. And they had a bag for those coils. And so I wound things to that bag. It turns out when I put it on the air, it wasn't even on the handbag. It was completely, it just wasn't right. So I figured out, got it taken care of. So what I did when I put my presentation together, I put together an exact bill of material. So that if somebody wanted to build that, they could follow that guide, they could build that antenna. Do you have such as that for this?
I can construct it. I mean, it's basically going to be, if you're going to run a level of power, get your balance from Palomar Engineers.
Yeah.
And if you're going to, you can get a 600 watt rated terminating resistor from Palomar Engineers. So you can buy it. You can get your ladder line from any of the ham stores. You can go and buy this now. You don't have to go and fabricate anything or use anything exotic.
Yeah, I want to 600 watts or less. So that is
Right. So my linear gives me like 1,300 on 20 meters if I want to run that. I wanted to have enough headspace in the terminating resistor to handle that.
Yeah.
Now, that brings up, I've not actually ever burned out I've never burned out any of the resistors on the network from operating. However, nearby lightning strikes occasionally will take one out. Because it'll just induce that much energy into the antenna. Of course, a direct hit, all bets are off. But the nice thing about this is you can go and just unscrew, unsolder, and replace the individual resistors. Any other questions? Okay, thank you all very much. Back to the Imperious.
Thank you, Bill. Appreciate you coming out.
Uh-oh, they found me. Anyhow, thank you, Bill. Thanks for coming out doing this. Bill will be making all these antennas for everybody here tonight.
I got 3 folded dipoles in my warehouse right now.
So, anybody have anything else? Any more questions for him? Any other information for the club? Well, there's got to be something out there. Hamfest?
So give us that date, the new date on the Hamfest again.
February 20th to 21st, 2026. Even though it's probably on the HoustonHamfest.org website, I got to check it to verify that it's correct. So don't look at it for another couple of days.
Okay.
So for our program next month, it hasn't been chosen yet, but we're going to hopefully have something here in the next couple of days. I'll figure it out. And the ice cream social in October, chili supper and elections, and homebrew night in December. Elections, if you'd like to get involved with the club functions and everything, there'll be several positions open. Blake's going to run for president.
I did tell you I would do that.
You did, didn't you?
You fool, you fool.
So,
I have time in my life.
so lots of, there'll be several positions open: president, recording secretary, corresponding secretary, treasurer. Dave's got all the money he needs for his round trip tickets everywhere.
Yep. Australia sounds good.
So he's going to step down, and we'll have one 2-year directorship open. So we'll see what happens on the next election and everything. It'll be great to get folks stepping in and moving the club around. So if nobody has anything else, I think it's time to go home. After 650 miles that I drove on Tuesday, it's time for me to go crash.
Nothing.
Thank y'all for coming tonight.
Nothing.
Don't forget the magazines back here.
Yeah, Pump doesn't want to take the magazines home, so everybody please take home the magazines. Thank y'all for coming tonight.
Okay. All of you out there in computer world, thanks for joining us tonight, and same time, same channel next month.
Thank you for putting it on.
You bet. Have a great night, guys.
Well.
I forgot to ask them about it.